I'd like to introduce our next session, which is Optical SETI and the Detectability of Directed Energy Systems. It is my great pleasure to introduce Dr. Jill Tarter. She holds the Bernard M. Oliver Chair for SETI Research at the SETI Institute in Mountain View. And she is the particularly appropriate person to discuss this and to lead the session on this. She spent the majority of her professional career attempting to answer this incredibly human question of, are we alone, by searching for evidence of technological civilizations beyond Earth. Jill?
Back in 1959, a paper in Nature by Phil Morrison and Giuseppe Cocconi launched this modern exploratory science that we call SETI. Radio astronomer Frank Drake conducted the Project Ozma, 21 centimeters, hyperfine transition of atomic hydrogen in 1960. This is for the students in the room. This is all ancient history to you. And thereafter, radio search programs proliferated both in the States and in the former Soviet Union. But in 1961, another Nature paper, this time by Robert Schwartz and Charles Towns, argued the merits of interstellar communication using optical masers, but laser technology was less mature, more expensive than radio, and it would be decades before it became possible and affordable for terrestrial observers to count photons quickly enough or to achieve the extreme spectral resolution that was required for the detection of extraterrestrial laser signals that arguably could be outshining their stars by orders of magnitude, right? So in the closing decade of the 20th century, Al Betts, a student of Charles Towns, had begun using one of the elements of Towns' infrared spatial interferometer to survey nearby stars for beamed monochromatic CO2 lasers. Stuart Kingsley at the Columbus Optical SETI Observatory began using his backyard equipment to demonstrate the feasibility of an amateur SETI, optical SETI program, and to convince Barney Oliver, the retired director of HP Labs and an expert consultant to NASA, to convince Barney of the superiority of optical photons over microwave photons. Dan Wertheimer at UC Berkeley and Paul Horowitz at Harvard began pioneering the sort of anti-coincidence detection techniques that are necessary to achieve tolerable false positive rates in searches for nanosecond broadband pulses. And then at the turn of the century, a series of workshops that was organized by the SETI Institute analyzed the current state of affairs, 3 decades past Project Cyclops, and attempted to create a roadmap for the next 2 decades. It was published as SETI 2020, and this is a signed copy for Yuri, with many thanks. The authors of this report were concerned about sensitivity, or really the lack thereof, to transient transmitters. And they concluded that the holy grail, all the sky at all frequencies, all the time, can already be discerned on the horizon for radio technology, and its optical counterpart cannot be far behind. Well, it's now almost 2020, and a whole lot has changed. Extremophiles and exoplanets have been game changers in the exploration of life beyond Earth. SETI across the spectrum is more timely, I would argue now, than ever. Searches for optical pulses have pushed down into the near-infrared, where the photons enjoy a less disrupted journey through the interstellar medium. All sky, all the time, may become a reality, at least for very bright sources, at optical wavelengths before that becomes possible in the radio regime. Optical SETI can not only be conducted commensally, but it is also amenable to data mining within archival material. And the fiducial for optical SETI in the field has long been a petawatt transmitter, laser transmitter, focused by a 10-meter telescope, even though we don't have any signs of that kind of technology in our future, at least for interstellar communication. However, what Breakthrough Starshot earlier this week demonstrates is that there's now a reason to believe that there may be transient, detectable sources of emission that result as the byproduct of other plausible activities, activities that may well legitimize the notion of throwing information-dense rocks, animate, inscribed objects between the stars, and not having necessarily to wait so long for them to get there. And we'll hear about all those kinds of ideas in today's session. And in thinking ahead, I'd like the audience and the panel discussions to be thinking about, are we doing a good job at prediction? Are we doing any better than this tome? Have we completely missed some emerging technology or economic driver that could rearrange all of the search priorities? The discussants in today's panel following the session will consider such questions. I have a bunch, and I hope the audience will also come up with their own.